Problem 8. A particle moves along the x-axis so that its velocity at time t is given by this velocity formula. At time t equals 0, the particle is at position x equals -3. Part A. Find an equation for the acceleration of the particle. Okay, acceleration, if I'm at velocity, I know the acceleration is going to be the derivative of the velocity. So the derivative would be -6t squared plus 5, and that would be it. Then it says to find the acceleration at time equals 2, so when I plug in 2, I've got -6 times 2 squared plus 5, that will give me -19. Right, find all times t in the open interval 0 to 3 when the particle changes direction. If the particle changes direction, I know that the velocity is going to go from positive to negative. So I need to actually make a velocity chart, and to do that, the first thing that I need to do is figure out where does the velocity equal 0. Okay, when I'm figuring out where the velocity equals 0, I'm going to take the velocity formula and set it equal to 0. Okay, we really do not have a way to factor this at all. This is a calculator section problem, so I would definitely suggest graphing it. When you graph it, I believe, I don't remember exactly what it looks like. I think it looks something like that off the top of my head, but I'm not exactly sure, so don't quote me on it here. But what we're going to be looking for is this 0 right here and this 0 right here. We don't care about the one that's over on the negative side because this only goes from 0 to 3. Okay? If you use the 0 feature of your calculator, if you don't remember, go way back to chapter P and look that up. Otherwise, to find the 0, when you do that, you're going to get t equals 0.203, and then you're also going to get 1.470. Okay, so now we're ready to do a velocity chart. So I will put 0.203 and 1.470 on it. Okay, I need to test something over to the left, and one nice thing, I already have a picture, so I don't need to do much testing. Before 0.203, you'll notice that the velocity is underneath the x-axis, so those values would be negative. Between 0.203 and 1.470, you'll notice that the picture is above the x-axis, so all those values are positive. And then after 1.470, the graph drops below the x-axis again, so all of those values are negative. Okay, so we can say, where does the particle change directions? The particle changes direction at 0.203 and at 1.470. Okay, it was not enough just to find the values. I had to actually test them to make sure the particle actually changed direction at those points. Okay, part C, during which time does the particle travel to the left? So basically all I need to do is look at my negative values for velocity on my velocity chart. So the particle travels to the left from 0 to 0.203, and then again from 1.470 to 3. Notice I stopped at 0 and 3 instead of infinity because I was given limits. And why did it travel to the left? We would say because velocity is negative. Make sure you don't say because it is negative, because we need to make sure we know what you're referring to. All right, part D. Find an equation for the position of the particle. So the position, I'm at velocity. To get to position, I know that I need to take the integral. So we're going to take the integral of velocity. I did call it x because it said it's moving along the x-axis. All right, so the integral of velocity would be the integral of -2t cubed plus 5t minus 1. Okay, I'm going to take the integral of each part separately. This one I'm going to have -2 t to the 4th, that will be 1/4 t to the 4th, and then plus 5 times 1/2 t squared, and then minus t. That will end up giving me, if I simplify it, I'll get -1/2 t to the 4th plus 5/2 t squared minus t, and then again also don't forget your plus c. Right? We are actually able to find the c in this problem because they did give us some information in the beginning. They told us that when t equals 0, my position is x equals -3. So we are going to end up getting -3 equals 0 plus 0 plus 0 plus c. So that means c is going to equal -3. So my position equation, I'm just going to write it down here, will be -1/2 t to the 4th plus 5/2 t squared minus t minus 3. Then it asked us to find the position of the particle at 2. So if I plug 2 into that equation, I will end up getting -3 as my answer. Okay, part E, find the total distance traveled by the particle over the interval 0 to 3. We did study this before. The total distance traveled is just equal to the absolute value of the velocity, so it's going to go from 0 to 3, and it's going to be the absolute value of the velocity, so it's going to go from 0 to 3. The velocity was negative 2t cubed plus 5t minus 1 dt. And again, this is on the calculator section, so we can go ahead and use the Math 9 feature of our calculator, and when we do that, we will find the distance traveled as 24.397. Okay, part F, find the average speed of the particle. Keyword here is average. If I want to do average, again, we'll use the formula 1 over b minus a, integral from a to b of f of x. Okay, so the first one will be 1 over 3 minus 0, or 1/3. The integral will go from 0 to 3. And then I'm taking the average of the speed. Well, we learned in the particle motion section of this chapter that speed is equal to the absolute value of the velocity. So in here, I'm going to put the absolute value of the velocity once again. And from here, again, since it's a calculator section problem, we can use the Math 9 feature of our calculator, and when we do that, we should get -7 as, no, we should not get that. We should get, I'm not sure exactly what answer we should get, but we will have to discuss that. But you will just type that in your calculator and get an answer. I don't think I have the right one on my paper.